On Earth, we have the sun close to our planet, and it gives us an excellent level of light so that we can see everything around us in wonderful colors. At night, we see a darkness because the light of the sun is gone. Our sun is like many of the stars that we see at night. Each one of the stars is a kind of sun in its own location. So if the stars are all giving off light, why is space so black? So in this video, we're going to talk about why is the universe black? The video is going to be amazing, so make sure you stick to the end. When the most powerful telescopes ever made gaze out into the vastness of space, they are essentially looking back in time. We're able to see 46 billion light years in every direction, while any light source beyond that distance has not had enough time to reach us. Even when we focus those incredibly powerful telescopes at a tiny point in space, one that appears to be completely black, light still reaches our observation equipment, and we find even more stars and galaxies. The number of stars and galaxies is staggering, and difficult for our brains to even comprehend. Galactic distances are almost inconceivable, so for all intents and purposes, the universe often seems infinite. The Earth is surrounded by an atmosphere that contains water droplets, dust, and dirt. When light from the sun hits any of these objects, it scatters or bounces off, and causes us to be able to see the various colors. It is our atmosphere that gives us the ability to see the light and the colors. Space does have some gas and cosmic dust, but there isn't any atmosphere. Light will travel in a straight line until it hits something. Once the light hits and bounces off an object, it is the atmosphere that allows the scattering and the ability to see colors in the spectrum that our eyes see. Before we move on, support us by hitting subscribe and the bell icon to get notified when we post new videos. Now let's get back to our topic. The surrounding space appears black because there isn't a strong enough atmosphere to cause the scattering. You would think that since there are billions of stars in our galaxy, billions of galaxies in the universe, and other objects such as planets that reflect light, that when we look up at the sky at night, it would be extremely bright. Tenley Hutchinson Smith, a graduate student of astronomy and astrophysics at the University of California, Santa Cruz, told Live Science in an email, "But instead, it's actually really dark." One of the theories that scientists have developed is that the universe is expanding away from the Earth, and therefore the light of the stars is also moving away. When they move away, the light wavelength gets longer, and the longer the wavelength, the less visible light we have, until there is no light that we can see. You know that when you hear an ambulance, it sounds higher pitched and louder the closer that it is, and the sound gets lower as it gets farther away from you. This is known as the Doppler effect. The final piece to this puzzle is that scientists have come to realize that the universe isn't as old as some originally thought. It is believed to only be 15 billion years old. This may not be old enough to allow the light from all of the stars to actually reach the Earth so that we can see it. Aside from the physical aspects of the universe that affect the general blackness of space, there are also limitations of our vision. For example, human beings can only see light in the visible spectrum. On the electromagnetic spectrum, however, the visible spectrum is a narrow band, bordered on one side by gamma rays, X-rays, and ultraviolet rays, and bordered on the other by infrared, radar, microwaves, and radio waves. These different types of radiation, forms of light, are created throughout the universe and pumped out among the stars, but we're unable to physically see that light without specialized sensors. Most importantly, at the very start of the universe, the Big Bang, the entirety of the mass now present was contained at nearly infinite density and temperature before it rapidly began expanding outward. All of that radiation, heat, and energy, in theory, would therefore be distributed evenly throughout the universe as it expanded, meaning that we should be experiencing and witnessing it from every direction all the time. So that's it. Please like, share, and comment your thoughts below if you like this video. Remember to subscribe to see our next video. Stay safe, and we'll be back soon with another video.